Hello friends, I Pankaj Dumka welcomes you all to this lecture on fluid mechanics. In this particular lecture, we will be discussing on the hydrostatic forces which are acting on plane submerged surfaces. So, let us consider the free surface of water. Okay, and in this free surface within the water, there is mm, a plane surface. That means a surface on which if we draw number of normals at different point, then all the normals will be parallel. So this is a plane surface which is submerged in the fluid and which is inclined at an angle of theta with the free surface. So the question is, what is the force acting, what is the hydrostatic pressure force acting on this particular plane surface if this is inclined at an angle of theta, and assume that the water is acting on the left side, on this side of the uh, plate. Okay, so how this surface looks like? So if you look from here, let us say that this is the shape of this particular surface. Okay, having cross sectional area, having surface area A. Okay, now we all know whenever we have a static fluid of constant density, then the pressure at any point is given by rho g h, where h is the depression from this free surface. So to start with the force which is acting on this particular area, we assume a small elemental area dA on the surface. Okay, so if you want to see where this area is on the surface, so this is where this elemental area is. Now let us assume that this particular area is at a depth of h from the free surface. So the force which is acting on this particular area, let us say dF, the hydrostatic force, will be given by the pressure at a depth of h in excess of atmospheric pressure, which is rho gh times the area, that is dA. Now for the sake of simplicity, assume this axis to be y-axis and the normal axis, this one, to be x-axis. Okay, and along the y-axis this element is at a depth of y. Okay, then from the geometry you can appreciate the fact that h is equal to y sine theta, that is h is equal to y sine theta. So you replace the value in the expression of force, you will be getting rho g y sine theta dA. So this is the force which is acting on this elemental area. So the total force acting on the surface due to the fluid above it will be the area integral of this dF, which is rho g y sine theta dA. Now as the fluid is incompressible, g is a constant and theta is also a constant, so they will be coming outside, and in integral it is y sine theta y dA which will be left. Okay, now what is y dA? Y dA is the first moment of area about x-axis. So you know the first moment of area will give you the centroidal location. So let us say that this this is the plate. Okay, so this is the centroid, this is the CG of the plate. So this is the one, this is center of gravity of the plate. Okay, so this center of gravity, let's say, is at ycg location from the x-axis. So this ycg will be equal to 1 by a integral area integral y dA, that is first moment of area. Therefore I can write this expression of f as rho g sine theta times this a y center of gravity. So A, y center of gravity. So again, if I combine the things, so it is y center of gravity sine theta. Now let us say that this center of gravity is at a depth of hcg from the free surface. Then this hcg will be ycg sine theta. So the expression of force now becomes rho g a h center of gravity. So the force which is acting on any plane surface which is inclined at an angle theta with the free surface and submerged. So the force which is acting is given by rho g a h center of gravity. Now the next question which comes is where this force is acting. Okay, so to understand that, let me give you a situation. Consider that this is a plate, any surface or any bar, let us say. Few forces are acting, F1 and F2 and F3. Okay, and with respect to this, I have to find out the position of net force. So the net force, that is the resultant force, will be given by F1 plus F2 minus F3 in horizontal direction and right direction. Okay, so this is sigma F. So if these forces are at location of Y1, Y3 and y2 from this, so the resultant force will be acting at what point? F1 y1, F2 y2, F3 y3 by y resultant. So okay, so the position of this resultant force, that is y resultant, will be given by this, or in other words, this is nothing but sigma Fy by Fr. Now these are single forces acting at a point. So if continuous force is acting and that is varying, then you have to write it as uh, integral of this y. So that is what we are going to do here. So this is area. Force acting on this area is df. So we'll be taking the moment of this and integrating over the whole surface and dividing it by the net force which is acting. So the position of let us say center of pressure, or the position of net force, is y center of pressure. So F times y center of pressure will be area integral of y times df. Okay, so this is y. What is df? It is rho g. It is rho g y dA sine theta. So rho g y dA sine theta. And so y center of pressure becomes, look, rho is constant, g is constant, sine theta is constant, so it will come outside the integral and you are left with area integral of y square dA divided by this net force, and net force in terms of y cg is rho g a sine theta y cg. So this rho g and rho g will get cancelled. The sine theta will be also getting cancelled. So the position of center of pressure is second moment of area by a y center of gravity. And what is second moment of area? Second moment of area is what we call as moment of inertia, and this is with respect to what axis? X axis. Okay, so I also assume that this is the centroidal axis y prime, and let me use different pen. This is centroidal axis y prime, and this one is x prime, x prime. Okay, so this now can be written as I x x by a y center of gravity. Now you all know, if you have an object and this is the centroidal axis, let us say x prime, and this centroidal axis is acting at a distance of, let us say, y from any reference axis xx, and you are interested in knowing that what is the moment of inertia of this area with respect to this axis, provided this is known to me. So that is what we called as parallel axis theorem. So I x will be I x prime plus area of this surface times the square of the position of the centroidal axis from this axis which is parallel to the centroidal axis. So this is called as parallel axis theorem. So if we use this y center of pressure, because centroidal axis parallel to x is I x prime, so this is I x prime plus a y center of gravity square divided by a y center of gravity. So this y center of pressure becomes I x prime by a y center of gravity plus y center of gravity. Now you can very well appreciate the fact that the y center of pressure is lying below the y center of gravity, and this is what we called as eccentricity of center of pressure from the center of gravity. That is, the resultant pressure force will be acting below the center of gravity. So this eccentricity is what I x prime by a y center of gravity. So if you look the figure, so if you look the figure, so why this is so? Now, if I draw the pressure triangle here, okay, if I draw the pressure triangle, so this is the pressure triangle, and that is how the pressure forces are varying. Okay, so if I focus only on the plate, then I can see that from the starting till the end, there is the variation, and that is continuously linearly this pressure force is increasing. So in the later part, this will be getting more bulky. That's why the center of gravity of this shape is acting somewhat below the CG line. So that's why the the resultant pressure force is acting somewhat lower than the position of center of gravity. So this is your resultant force and this is your center of pressure. Now this distance is what we call, oh sorry, this distance is what we call as eccentricity. Okay, so always remember that the center of pressure will always be lying below the center of gravity by an amount this. Okay, and one more thing, that center of gravity and center of pressure will approach each other only when y center of gravity is tending to infinity. That is, when the plate is very far within the fluid, then only the y center of pressure will be approaching close to center of gravity. Otherwise there will be a substantial difference between them. So in this lecture, we have learned how to evaluate the pressure force which comes onto a surface which is submerged in fluid, and that surface has to be plane, which is inclined at an angle of theta. And remember, in this particular case, we have assumed that the fluid is incompressible. That means the density is a constant. Okay, and also we have developed an expression to evaluate the position of the center of pressure. Remember, in this analysis, we have assumed this line, this y axis, to be the symmetry axis. That is, it the center of pressure will always be lying along this. If not, then we have to find out the location, that is x center of pressure also. But in this particular case, it has assumed to be the on this center line, on this symmetry line, so no problem at all. So in this lecture, till this point only. If you liked my video, then please do like, share and subscribe. Thank you very much.